This video is to help you with the Hess's Law section of chapter 17, assignment number 2. Because if I would have been in class today, we would have done these problems together because they can be difficult, okay? I am going to start with number 9 because I think number 9 is the more difficult of the three. And then maybe do number 8 as well. And then you'll have to do number 7 by yourself. Okay, because I would have done for sure number 9 with you in class. So the idea of these problems is that we are trying to create this reaction that's here. This is the overall reaction for this series of step reactions, okay? And when we manipulate the bottom equations and change their delta H's, when we're all done, the values that we're starting with add together and give us the overall heat of reaction for the overall equation, okay? So what do? What I do is I first just start with the first reactant. You're looking for two things. You're looking, is it on the correct side of the arrow? Is it a reactant or is it a product? Down below in one of the reactions. And then, so like, is it on the correct side? If it's not, you flip it and you change the sign on the delta H. If it is not having the correct coefficient, then you will multiply or divide to get it to have the correct coefficient. Okay, so let's just start with this first one. So the first reactant is NO, 1 oxygen. It's on the reactant side, so it's on the left side of the arrow, and it needs a coefficient of 1. So the NO, I see it right here in this third reaction. It's currently on the left side of the arrow as a reactant, and it currently has a coefficient of 1. So that means that we are not going to change the third reaction at all. So on the left side, I just put little notes to myself about what I'm doing. Okay, now, just by the way, in that same reaction, we have our product that we need. And it's already perfect as well. It's on the right side of the arrow, which it needs to be, and it already has a coefficient of 1. So those two parts of that bottom equation are perfect for us. Okay, now, the only other thing that we need is O, and it's an O with no subscript. So we've got O's all over the place in here, okay? The O with no subscript is this O right here. It's in the second equation, and it's on the product side, okay? So that's on the wrong side of the arrow, which means that we are going to have to flip the equation to get it beyond the left side of the arrow. And it has a coefficient of 2, but it needs a coefficient of 1. So besides flipping, we also will divide everything by 2. Okay, so when I do my changes, I rewrite it underneath and then I cross it out when I'm all done. So flipping it around, the O with no subscript will be on the left side. And we're also dividing by 2. So it had a 2, so now it just gets a 1. And then the product side, we have the O2 that's on the other side of that, but it used to have a coefficient of 1, and now we're dividing by 2. So that turns the coefficient into 1/2. We can't forget that there was a 1 there to start, okay? And then to change the number, like we change the equation, when we flip, we change the sign, so it becomes a negative 495. And then we have to divide that by 2. So when you divide by 2 with a negative 495, you get negative 247.5. Okay, so now that I've done all those changes, I'm going to cross off the entire middle section so I don't look at it anymore. Okay, so by now doing that, the O is where it needs to be. It's on the correct side of the arrow, now it's the correct coefficient. But the reason why there's a third equation is so that you can cancel out things you don't need. The things we don't need are the O2s and the O3s, all those other things, okay? So the top equation is just there to help us cancel out stuff we don't need. And the way that we cancel them out is they have to be on opposite sides of the arrow. So now, what the key for me is I see that O3 is on the left side and that equation I said is not changing. And O2 is on the right side in that equation I said that's not changing. And if you look in the top equation, they're not in a situation where they'll cancel. They're on the same side, so they're actually gonna add if we don't do anything about it. So if we flip the equation around, so I'm talking about this one, I'm gonna flip it around so that O3 and O2s flip-flop their sides. That's a good start. And then also, we have a 2 in front of this O3, but there's only a 1 O3 down here. And so if they don't have the same coefficient, they're not going to cancel out. So that means I have to divide by 2 as well to that top reaction. Okay, so now let's flip it and divide by 2. So the O2 will go on the left side of the arrow. The coefficient, it starts with a 3, and we divide that by 2, so it's going to become 3/2. Then the product side, we have the O3, and it had a coefficient of 2, divide by 2, that becomes a 1. That's great. Okay, so now the delta H number, don't forget about that. Flipping makes it change sign, so it was negative before, so now it's going to be a positive number. And we take the 427 positive divided by 2, and you get 213.5. Okay, so that makes us forget about this top equation because now we've changed it. So we have done all the work that we need to do. We've looked at all 3 equations and decided how should they change or should not change. And now it should work out. Okay, so adding together everything that we have, the O3s, we did this on purpose so that the O3s cancel away. So that's good. Now the O2s, if they're on the same side, like this 1/2 O2 and this 1 O2, if they're on the same side of the arrow, they add together or they combine together. And so those two combine together to cancel out the 3/2 O2 we have on the left side of the bottom equation now. Because these two added together would be like 1/2, right? Which is equal to 3/2 in fraction form. So they all cancel out. So just get rid of all of those O2. They're all gone. Okay, and that's it. Everything else is canceled. So we're left with the NO plus O to make NO2, which is what the overall reaction was, which is good. So then now, the whole reason why we're doing this is to add the numbers together. So you take the negative 199 plus negative 247 plus 213.5. And the answer is negative 233 kilojoules. All right, so I told you this one is one that doesn't make a lot of sense because of all those like adding to cancel, you know, it's a lot. I get it. Let's look at number 8. I'll be nice and read number 8 with you. Okay, so again, this is the reaction we are trying to make out of the bottom 3. Okay, the reason why we're doing this is to find the delta H of that reaction. So the 3 reactions in the bottom are going to help us get there. Okay, first reactant. It's carbon by itself, and it needs a coefficient of 2. So it's got to be on the left side of the arrow, needs a coefficient of 2. I see carbon by itself in the second equation, but it doesn't have the correct coefficient. It's on the correct side, so we're not flipping this time, but it doesn't have a 2. So that means for everything in the second reaction, we're multiplying by 2. Okay, so that's going to turn into 2 carbon plus 2 O2 arrow 2 CO2. And we're going to keep it in negative 394 but take that times 2 and you get negative 788 for that. And so we'll cancel that out, so I don't look at it anymore. All right. And I'm a type of person, I like to box them, so I know they're good, so I don't forget and I don't accidentally cancel them out later, if that's helpful to you. Okay, next reactant that we need to worry about is the H2. Needs to be on the left side of the arrow, and it needs a coefficient of 2. Well, in the bottom equation, it is already there. It's perfect. It has the correct coefficient of 1. I'm sorry if I said 2. I'm a little out of it right now. So that's perfect. We're not going to change anything about that third reaction because the H2 is perfect. Okay. The last one, we're looking for the C2H2. Well, it's probably in the third equation, right? So the C2H2 is currently a reactant. It has the correct coefficient of 1, but it's not on the correct side. So this is a case where we will flip to make it work. And so we just flip around reactants and products. So the 2CO2 plus H2O will go on the left, and then arrow C2H2 plus 5 halves O2 on the right side. And then delta H, just change the sign. When you flip, you change the sign. So it was negative 1300 before, so now it's going to be a positive 1300 for the new flipped equation. And then cross that out so you don't look at it anymore. Okay, so we had 3 reactions and we looked at all 3 of them and it's decided what to do. So at this point, we should have done it right and they should work out when we add them together. Okay. Oh, I forgot to put a box around this one so I don't forget to cancel it. Okay, cancellations. Here we go. The 2 CO2s, that doesn't need to stay. And we've got 2 on either side of the arrow in the 2 different reactions. So those are gone. The H2O, there's 1 in each equation, and they're going to cancel because they're on opposite sides. Now, the O2s just seem to be the problem, right? So we've got 5 halves O2 right here, and we've got 1 half, and we've got 2. Remember when they're on the same side, they combine together. 2, if you put that in fraction form, would also be the same as 4 over 2. So 4 over 2 plus 1 half, 1 over 2 makes 5 over 2. So the O2s all cancel each other out. Yeah. Okay, so what we're left with is 2C plus H2 makes C2H2, which is what we were looking for. We did it right. Last but not least, add the numbers together. So negative 286 plus negative 788 plus 1300. And you will get a positive 226 Kelvin for that answer. So now I've done 2 out of the 3 problems with you. No reason why you can't have everything through number 9 done before you leave class today. But this isn't turned in yet because we still have a little bit more to learn. You need to do number 7 yourself. And if you want to ask nicely with the sub, they have the answer key and they can check your answer for you.